Hi, what I'm going to do in this video is go through some thinking skills questions as a bit of a revision before the upcoming selective school exam. So the first area I'm going to look at is assumptions. So basically an assumption is a leap in logic. That's the important phrase to remember there. It introduces an element that hasn't been discussed before in the argument and tries to make it seem obvious that the newly introduced element is inextricably, so that might be a word that some students don't understand. To extricate means to set free from or to escape from. So when something is inextricably linked, it can't be escaped from, or it can't be separated in this context. Inextricably linked to the previous reasoning when the critical reader can quickly see that it isn't. All right, let's highlight the word critical. Yeah, that's the all-important word in thinking skills, I think. And I think I'll show you how I try and teach students to be very critical of all these arguments that they read. All right, in the sample question below, firstly, try to identify the newly introduced element or leap in logic. All right, so as I go through it, I'm going to point out to you some words that I think you should try to critically analyze as you read these arguments. All right, there is clear evidence. All right, so this adjective clear, if someone were to read that, or you were to read that in an argument, you might think, okay, well, why is it clear? All right, why are you giving it that adjective? Why don't you just give me the evidence or the data? So there is clear evidence that it is more. Okay, more is a very meaningless term. All right, how much is more? Is it 1% more? Is it 1,000% more? Okay, so yeah, it's really meaningless. Difficult is also a similarly meaningless term in most cases. I remember when I did some thinking skills questions with a very intelligent student, and the student told me that the questions were not difficult, and I told her, no, they are difficult, you're just very clever. All right, so yeah, the term difficult is completely subjective. Subjective means open to opinion and not based on fact. All right, so there's clear evidence that it is more difficult to score high. Yeah, you get the idea by now. All these words, all these adjectives are pretty meaningless. High examination grade in certain subjects. Yeah. For example, mathematics and foreign languages are much more, again, more meaningless jargon, difficult than most other subjects. In that a smaller percentage, again, how much smaller, of those who take the examinations gain a high. What's a high grade? Because schools in Britain want good. All right, what's good? They do not encourage students to choose these subjects for their advanced level examinations. This is why there is a decline in the numbers studying for university degrees in these subjects. Now, since is an important word, could highlight the conclusion to the argument. Since the economy of the country is of prime concern, a policy of encouraging those with aptitudes for mathematics and languages should be introduced. All right, so where is the leap in logic in this argument? So the leap should be where something is newly introduced that hasn't been discussed. So we've had this whole argument that has talked about how grades in these certain subjects, high grades, are more difficult to achieve. So therefore, because Britain wants to make it look as though they're achieving good results, they don't want people to study those ones. So we go on and on and on about that. And then here we introduce the economy. All right, the economy. So yeah, when you're reading this, you should be thinking, hang on, you haven't said anything about the economy up till now. And now you're saying since the economy of the country is of prime concern. So why are you saying that? Where's your evidence for that? So the leap in logic is, I'll just fill in some text there, the economy. All right, let's scroll down. Now locate the answer choice that aligns with your identification of the leap in logic. So which one of the following is an assumption underlying the reasoning? So yeah, normally the question for an assumption type question, the actual physical question, is to do with the assumption underlying the reasoning. So you wouldn't even really need to read through them all. I mean, you could do that, but you can see that B is the only one that states or includes the economy. Right? A successful economy needs people with advanced skills in mathematics and languages. Right? It's clearly an assumption because we went from all of this discussion about the grades to just jumping to the economy of the country as a prime concern with no discussion of why grades link to the economy. Let's say, for example, if you were talking about an economy in a country that was that was rich in natural resources like oil, for example, yeah, you could just mine the oil and sell the oil, and you might have a booming economy, and it's got nothing to do with your study of mathematics and foreign languages, right? So beyond just being an assumption, it seems a complete fallacy as well. Many places could have very strong economies without having those skills. So a successful economy needs people with advanced skills in mathematics and languages is the leap and is the assumption made here. All right, let's just read through the other choices. Students should be required to take examinations in mathematics and languages. Well, that's not an assumption. It's come right out and stated that. There are many people who have an aptitude for mathematics and foreign languages. Yeah, it's kind of an assumption, but not really underlying the argument. Schools in Britain think that mathematics and languages are not important subjects. Well, no, it doesn't say that at all. It's not an assumption. It's just saying it's more trying to mask that. They may know that or they may adjudge those subjects as being important, but they want to obfuscate, which means to sort of cloud. They want to cloud their results by doing other subjects. All right, let's have a look at some other assumption questions to see if that same strategy works quite well. A new computer has been developed. All right, well, let me highlight the words as we go. New. All right, so what should you be thinking as you say new? What does new mean? How new is new, right? Did it come out 1 second ago? Did it come out 1 week ago, 1 month, 1 year, 5 years? You get the point. A new computer has been developed that can process 3 million possible chess moves per second. See, that's actually better data, right? 3 million possible chess moves per second. See, is that a lot? Who knows, right? Who knows how many possible moves the best human player might be able to calculate, right? It might not be anywhere near as much as that, but I need some frame of reference in order to be able to ascertain whether that's a lot or whether that's a small amount. Recently, this computer beat the best human chess player in the world, even though he had undergone a daily 13-hour training program in preparation for the match. Therefore, so that's your highlight of the conclusion, just like you had since in the last question, humans can no longer claim to have the highest level of intelligence on the planet. All right, do you see the leap in logic? For most of the argument we talked about chess, right? A machine, computer can beat human in chess, and then they go on to intelligence. All right, now a good way for a student to think about this would be to think if they are intelligent, right? Like let's say if a teacher or a person's intelligent, they might not play chess, right? So why did we go from chess to intelligence, right? The two are not necessarily even correlating, I wouldn't think. All right, so the leap in logic is the introduction of, let me just get it, of intelligence. Now locate the answer choice. There are many. Skill at chess playing is a reliable indicator of intelligence. See, even though intelligence is mentioned in a lot of them, we have to make the same leap. So we went, what's the assumption? Skill in chess playing was the bulk of the passage. Reliable indicator of intelligence. So it should be A. All right, I'll just highlight that. A. All right, skill. There are many different aspects of human intelligence. That's quite possibly true, but it's not an assumption that underlies the reasoning in this passage. Computers will continue to develop at a rapid rate. That's not really mentioned, not even alluded to. Computers are only as intelligent as their inventors. Again, that's irrelevant to the argument. So finding the leap in logic and moving on from that. Okay, there are many reasons why we conceal our emotions. All right, I'll just get into the highlighting. Many, what does that mean? Why we conceal our emotions. Uh, Embarrassment, not wanting to appear rude, to avoid an argument, to deceive others. Most of us, all right, how many is most? Find it hard. Yeah, what does hard mean? To read people's emotions when they are hiding them. However, we do get very small. What does that mean? Or micro expressions when we are not being honest about how we feel. And 1%, yes, I'd rather have the percentages of the population is good. What does good mean? Reading these. Sometimes, yeah, that's really vague language. Sometimes it would be beneficial if more of us were better at reading emotions. The police might, okay, yeah, such a low modality, treat you better if they were able to read the subtle. All right, subtle is a word I often have to explain to students. It just means not very emphatically. It's sort of done in a gentle way, a sort of covert way. Subtle signs that would tell them you were looking uncomfortable because being interviewed was shameful, not because you were lying about having committed a crime. Security officials might find it helped them to detect terrorists. It would be good if such people could attend government-funded training courses in how to interpret micro-expressions. Right, you had this whole long argument about how good it is to be able to read emotions, and then you just went, to this last bit, it would be good, which is your call to action. If such people could attend government-funded training courses, there's your leap in logic. We heard nothing about training in this area, right? So the leap in logic is, change that to training. Right, which one of the following is an assumption? And training, what phrase fits with that? It's that judging hidden emotions is a skill that can be learned. Right? It's assumed, right? You went straight from going on, and it would be like talking about how useful it would be to read minds or something, right? You know, telepathy would be such a useful skill, blah, blah, blah. And therefore you'd say it'd be good if people could be trained in telepathy, right? And it's like, yeah, well, would be good, but not possible going by current scientific knowledge. All right, what do the others say? Most of us are honest about how we feel most of the time. Very vague answer. Most of us feel bad if we are not being honest about our emotions. Yeah, so you could straight away rule out those answers. I think they're just so vague. Police and security officials would benefit most. Yeah, so they all had most in them, right? So you could probably rule that out. And the first one is the only one that is an objective truth, that it's not assigning some opinion to it. All right, question 3. On average, the life expectancy of people in the lowest income groups is much lower. All right, let's highlight some of these again. Lowest income groups, what does that mean? Much lower. Again, I'd prefer to know the percentages. Highest income groups. This is partly due, partly 1% or 99%, due to the fact that the higher one's income is, the more likely one is to have good housing. Yeah, what is good housing? Nutritious diet. Smoking is also a major cause of early death due to lung cancer or heart disease. All right, yeah, early death, what's that mean? All right, like for example, and major cause. So for example, men die quite significantly younger than women. So, you know, you would obviously perhaps look into smoking as a cause of that. But yeah, what is early? What constitutes early? Therefore, we can conclude, I'll just say this, whenever you see we in an argument, you should always be looking out for that. You don't want someone else to be speaking for you, right? I'd rather phrase this in a way, you know, it could be concluded, okay, or the evidence suggests. This would be a better way of writing this argument. A critical reader always sees when someone says we, it's probably a weak argument. They're trying to convince you of something by appealing to you as being similar to them. So therefore, we can conclude that smoking is a contributory cause of the difference in life expectancy between the richest and the poorest in society. All right, so they go on about how there's a difference in income and that affects health. The thing that gets introduced that just seemingly comes out of nowhere is smoking. I think it's smoking. So just write in smoking in there. And what's in the assumption? If we look for one that includes smoking, yeah, the assumption is smoking is more common in the lowest income groups than in the highest. All right, it's not stated that there's any link there. All right, it said they're more likely to have good housing and a nutritious diet. Smoking isn't really a part of a diet. So D is the answer. A, the richest in society are unlikely to die from heart disease. It's not really an assumption in the argument. Those who have a nutritious diet are unlikely to suffer from cancer. Again, doesn't really link to the argument. The argument is mainly about smoking. All types of cancer are more common among the lowest income groups. No. So the one that the leap in logic, which would identifying that would help you to answer this question, is finding smoking and thinking that, well, there's no evidence that smoking is more common. And if there is, it's not shown in the argument. All right, question 4. One argument against the existence of intelligent life forms on other planets is that if they did exist, then at least one of them would have developed the required level of technology to reach us by now. As there is no evidence that aliens have reached the Earth, there cannot be intelligent life elsewhere in the universe. All right, so a good way to think about this is to perhaps make an analogy, right, to what might happen with aliens, or to think about aliens in terms of the way humans are. And let's put humans into the position of being aliens. We're an intelligent species, right? We're not really exploring space. And in fact, there are many arguments made to say that we shouldn't have spent so much money on exploring space, right? So the correct assumption that is made here when you go, well, because they haven't done it, it means that there must not be any intelligent life. Well, you could say humans haven't done it, but they're intelligent life, right? So the evidence is not really compelling there. So the correct answer should be D. If alien species existed, they would want to explore space, right? That's assumed, right? It's assumed where, yeah, there might be a species that on another planet that has no desire to travel through space or to discover new planets. All right, now I'm going to go on to some more thinking skills questions. These ones will be more along the lines of problem solving, some ones that I've come across that I've deemed to be reasonably difficult, or different types of problem solving questions. On only 360 occasions during the 20th century was it possible to write the date in the form DDMMYYYY, so that's day, month, year, using 8 different digits. One example was 28th of July 1956. That's 2807 or 28071956. So you've used 8 different digits there. Which ones did we not use? It looks like 3 and 4 weren't used there. 11 of Arthur's birthdays have been such dates, though not his date of birth. And in 1974 and 1983, the 2 digits that did not form part of the date made up his age at the time. In which year was Arthur born? And there's your 5 choices. All right, so the first thing, now the big problem in a lot of these questions is going to be extrapolating the data from the question, figuring out what you need to do. So the first thing I would do here would be let me write the dates in there. So what are the 2 dates that it occurs on? 1974 and 1983. All right. Now, how many different digits were used there? The 1 and the 9 and the are repeated, and we've got 4, 7, and 3, 8. So what I would do from there is I'd write down the 4 digits that were not used. So let's go 0. We'll go in order. 1's been used. 2 hasn't been used. 3 and 4 have been used. 5 and 6 haven't been used. And from there, you should be able to figure out a possible date that you could have, or 2 dates. So let's go with something like 2506, and then we have the 2 years, 1974 and 2506, 1983. All right. Now, the other clue you were given was that the 2 digits not used would make up his his age at the time, made up his age. So which 2 digits did we not use in the first one? It's pretty clear because it has to be in the year. So it's the 3 and the 8. So the 2 possible ages could be 38 or 83. You only have the 2 possibilities. And in 1983, the 2 digits that were not used were 4 and 7. So the 2 possibilities were 47 or 74. Now, it should be pretty clear, I think, that it can't be 83 and 74 because his age is going down there, right? And it can't be, say, 38 and 74 because the gap needs to be 9 years, right? So in 1974, he would have been 38, and in 1983, he would have been 47. So if you subtract 38 from 1974, you get 1936. If you subtract 47 from 1983, you get 1936. So that is the, what have I done here? I haven't, want to highlight the text. Why is it doing that? Okay, wrong key. Yep. So, well, yeah, the answer should be D anyway. Okay, D, 1936. Okay, this one is, well, I'll read the question first. In Vengaland, the unit of currency is the won, which is divided into 100 cents. The coinage in use is shown below together with the weights of the individual coins. So you get copper coins, the weight, silver coins, the weight, gold coins, the weight. All right, shopkeepers are required by banks to put coins with the same weight value ratio. All right, ratio is the important word here. I don't know why it's changed to that. I'm using the underlined text. Must be some glitch in the program. Into bags, which can then be weighed when the money is deposited. For example, all copper coins can be put into the same bag since a 2-cent coin's weight is twice that of a 1-cent coin. So if we go back up to the 2-cent and 1-cent coin, you can see 1 cent, the value to weight ratio is 1 to 1.5. We could say 2 to 3, all right, which is the same here, 2 to 3. I'll just write that in there, the ratio 2 to 3. What is the smallest number of bags that a shopkeeper requires so that all his coins can be weighed when taken to the bank? All right, so these two, let's say 2 to 3, I'll call it A and A, they're both A, they're both 2 to 3, the ratio. All right, what's the ratio of this one? 5 to 2. You can't reduce that, all right? It'd be 2.5 to 1. So let's stay with that at 5 to 2, and that's a different ratio. We'll make that B. 10 to 4, that's also 5 to 2. So let's make that 5 to 2. 20 to 2, that's 10 to 1, basically. So maybe I'll write the ratio over here so we can track it. 10 to 1. 25 to 10, that's 5 to 2 as well, right? If you multiplied both those by 2.5, so that's another B. And 50 to 4, what's that ratio? 50 to 4, 25 to 2, we'll call that 25 to 2. I mean, I could go with 12.5 to 1, but it's possibly easier for younger children to keep track with using decimals. 25 to 2. All right, 1 won, here's where it might get a little bit harder. All right, a won is worth 100, so it's basically 100 to 10, which is again 10 to 1. And we already have another one that has that ratio. 2 wons, that's 200 to 16. All right, you can divide them both by 8 to get 200 to 16 is 25 to 2. So, all right, so we've got how many that are 10 to 1? We'll make those all the same. 10 to 1 there, 10 to 1 there. We'll make that C. And the 25 to 2 will make D. 25 to 2, D. So we have 2 A's, 3 B's, 2 C's, 2 D's. What is the smallest number of bags? A, B, C, D? 4. There's 4 bags. All right, so I'll just put that. So the answer is B. Now, I should say, I think it takes me longer to explain this, all right? You should be able to do this type of question reasonably quickly. I think if you're good at ratios, identifying ratios. All right, this question, when I did with students, really had trouble with this one. It's a good number pattern type problem, but it's within the facade of a word problem. So let's say, while cleaning out old documents, I came across various newspapers, but there was not a complete set. Only those with particularly interesting items had been kept. In some cases, it was a series of articles published regularly at fixed intervals. That's the important phrase. The table below shows which papers were kept in consecutive weeks, with the oldest in the top row. What was the longest possible series? All right, series is an important word, of articles which had been kept. All right, so I imagine, students would look at this. So it's okay, we got a tick there, ticks in different boxes. What does this all mean? So what you should ideally do here is think of it as a number series and start filling in numbers. So 1, 2, 3. Obviously, in each week, there's going to be 7 days, all right? And 7 actually helps you to fill it out. It'll help me first. So now that I know this one's 2, I know that's got to be 9 underneath it. That has to be 11. This has to be 12. Right, this one has to be 15 because it's 2 weeks on. This one has to be 19. This one, 9 plus 14, 23. This one, 6 plus 21, 27. Okay, then we have 3 plus 28, 31. And then we have quite a long series, 32, 33, 34, and 35. And we can stop there, and we know we're on the right number because it's 5 times 7, 35. Because there's a long gap there. All right, that gap of, 8 until the next one. It's not even possible. How many weeks do you have? 42, 49, 56. You have 8 weeks, 8 times 7. So it's unlikely 8 would be the longest possible series of fixed intervals. Fixed is the important word to notice here. All right, so let's go to the first tick. We go 3. What's the next tick? 6. All right, so there's an interval of 3. Can we keep going by 3? 3, 6, 9, 12, 15. There's no 18. All right, so there were 5 in that series. That's a possible answer. We're not sure if it's the correct answer yet. Let's try another series. Let's go 3 to 7. All right, how many is the difference there? 4. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4, 15. 15 plus 4, 19. 19 plus 4, 23. 23 plus 4, 27. 27 plus 4, 31. 31 plus 4, 35. Right, so there's quite a long series there of fixed intervals of 4. If you counted them up, 3, 7, that's the second one. 11 is 3. 15 is 4. 19 is 5. 23 is 6. 27 is 7. 31 is 8. 35, 9. Right, so there's actually 9. The longest possible series is 9. Right, you could stop it there because there is no higher answer than that. So that's a pretty tough question, I think. I quite like that question. I think it'll be a good one at differentiating between students who can identify quite difficult number patterns. All right, this one is another one that a lot of students have trouble with because it's the logic within it. All right, the coffee machine in our office offers a choice of regular or decaffeinated coffee, black, or with one of 3 sorts of milk, full, semi-skimmed, skimmed. And for those who want sweetening, either 1 or 2 spoonfuls of sugar or 1 or 2 non-sugar sweetening tablets. How many different kinds of coffee can be made? And you have the choices here. All right, what most students do is they say we have a choice of regular or decaffeinated, 2 choices. Right? And you go with 1 of 3 sorts of milk, all right, full, semi-skimmed, skimmed. And then for those who want sweetening, So you have those three choices of, well, actually, sorry, I missed. We have black or three sorts of milk. So you 2 times 4, black, and then the three sorts of milk. And for those who want sweetening, either 1 or 2 spoonfuls of sugar or 1 or 2 non-sugar sweetening. So in total, another 4 choices. And 2 times 4 times 4 equals 32. And most people go with that as the answer. So there's that many different types. Okay, this one is slightly different. All right, so you do start off with regular or decaffeinated. All right, then you have your 4 choices, black or 3 sorts of milk. And for those who want sweetening. So actually, for those who don't want sweetening, you stop there. All right, they only have 8 choices. All right, the ones who don't want sweetening stop. And then we continue on for those who want sweetening, which is still 2 times 4, right? Times the 4 other choices of the sweetening, which is 2 times 4 times 4 equals 32. So you have to add those two together. So you have 8 choices for those who don't want sweetening, 32 for those who want sweetening. And that means the answer is D, 40. All right, D40, hang on. Why is it? Now it's highlighting it. This program's very weird. All right, so yeah, the answer should be D40, not letting me do it. There we go. Okay, so yeah, not many students were able to identify that sort of fork in the road there. So we have 8 choices if you don't want sweetening and another 32 if you do. So 40 in total. All right, next question, another one to do with the digital clock type questions. A lot of these in these Cambridge tests I found. The individual digits on my digital clock appear as words rather than numerals. For example, at 18:07, 6:07, the display is shown as below, 1807. How many times each day does the letter E not appear? So not appears the important word there. So you've got to come up with the numbers in word form that don't contain an E. So you would go through those. You would say, what is the first one? 1 has an E. 2 doesn't have an E. Right, 3 has 2 E's. 4 doesn't have an E. We can have 4. 5 has an E. 6 doesn't have an E. 2, 4, 6. 7 has an E. 8 has an E. 9 has an E. And 0 has an E. So there's 3 different numbers you can use. Now you're using 24-hour time as well. So 2, 4, 6. So what can we do in hours? Well, we can, because we can only go up to 24, and we can't even go up to 24 because the biggest time, you can have will be 23:59. So you can only have 2 as the first digit, and you can have it as the second digit, 22, and you can have it as the 2 digits in the minutes as well, 2222, 1022. What would be the next lowest? 2, 2, 2, 4, and 2, 2. What would come next? 2, 2, 2, 6. All right, very close, those ones. All right, what do we do next from there? Can we keep going with 2, 2? We can. In fact, we can only have 2, 2 in the hours. Can't use 24, the next lowest, but we can go 2, 2. We've used 2 in the next digit. We've used that all up, so we go to 4, 22, 42, 22, 44, and the last one, 22, 46. And that's actually the answer. That's all we can do, because similarly in the minutes, we cannot have 6 in the tens column for the minutes, because yeah, obviously the highest amount of minutes you can have is 59. So the answer is, for this one, C6. Right, C6 is the answer. There are your 6 times: 22, 22, 22, 24, 22, 26, 22, 42, 22, 44, 22, 46. We have always applied the strict rule that the number of children coming to a birthday party should be equal to the age of the child. 7 for a 7-year-old, etc. Each guest brings a present to each party. Our children are now 3, 6, and 7. How many presents have been received in all? All right, so this one, once you have an idea about triangular numbers, I think is pretty easy to solve. So the 3-year-old, the child who is now 3, for example, when they were 1, they would have had one person come, one child come, and they would have got one present. So it's 1. Then when they were turning 2, they would have had 2 people come, each bringing a present. They would have got 2 presents, 2. And then when they are 3, the current age, it would be 1 plus 2 plus 3, which equals 6. So they've received 6 presents in total. Now the 6-year-old will actually just continue that series. All right, they also had 6 presents when they were 3. When they turned 4, you would add another 4, and when they turned 5, add another 5, and when they turned 6, add another 6. And that would all add up to, if you wanted to add that up quickly, you could just use the Gauss method. You could go 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7. It adds up to 21. Okay, so the first one was C. And then to get the child turning 7, we just need to add 1 more plus 7. And because we knew adding up to 6 was 21, that'll be 28. All right, so, and actually if you knew triangular numbers pretty well, you'd probably just even memorize that. Like for 8, you would know it's going to be 36, 9 would be 45, 10 would be 55, and so on. So we then add them all together. The 3-year-old had 6, the 6-year-old had 21, the 7-year-old had 28, 28 plus 21, 49 plus 6, 55. D55 is the answer. Okay, so yeah, that's a pretty easy one. Again, I think the problem is identifying what the question wants you to do. All right, the 6-digit passcode for my online banking account is easy for me to remember. It is the only 6-digit number that can be written in the form XXX. So there's a gap there, so you've got one 3-digit number, and XXX, another 3-digit number. There's 2 square numbers, so square numbers is an important thing, an important concept to be aware of. And in the form XXXXXX, 3 2-digit numbers. There's 3 different prime numbers, all right, so they all need to be prime numbers. All right, the 3-digit square numbers are, and you've got a whole heap of 3-digit square numbers, they're all square numbers. All right, so a quick thing you can do here is to try to identify within each of those, the one where there is a prime number, that is the first 2 digits. So let me have a look through that. There's 1, 19. It's a prime number, right? We can keep that one in mind. 1, 9. Are there any others? Let's say 67 could be a possibility. 67. Any other ones? Because we need 3 of them, in fact. 57 is 19 times 3, so it can't be that. They look to be the only 2, all right? So 2 square numbers, if they're the 3, so 6, 7, 6, and 1, 9, 6, well, we know they're all square. So what do we need? We need one more that will go between that. So we've got 1, 9, then we want one that is 6. So yeah, I don't think we are going to use this one, all right? Although no, since they both end with 6, they're both applicable. They both work, right? Because yeah, 196 and 676, they both work. They end in 6, so it would be the same middle prime number if you use the second square number in conjunction with either of them. And I think it'll be this one here, 729. All right, because 67 would be a prime and 29 would be a prime. Okay, so the first 3-digit could be either of these, I think. I don't think you can work it out. all right, which one it is. But they both end in 6. So that gives you the answer, because the question asks you what is the third digit of my passcode. So the two numbers, the 6 digits, could be 196729. Then you have 3 numbers of 19, 67, and 29, all primes. And if it was 676729, it'll be 67 prime, 67, 29, all prime. Does it say they need to be different prime? No, they're different. Okay, so see, I identified that they have to be different. So the answer is then 196729. All right, wouldn't have affected the answer anyway, but yeah, there's the importance in reading the question properly. They're different prime numbers. Good to know. Right, now I really think this question is also quite good because you have to have a good awareness of what prime numbers are. So, for example, a student who's not very good at it might think 57 is a prime number. Right? That's 19 times 3. And plus you can see, well, you add 5 and 7 together, you get 12. It's divisible by 3. So yeah, it is not a prime number. So anyway, the answer for that one is D6, because the answer is 196729. D6. All right. The following table shows the distribution of cats and dogs amongst the 80 households of Pluvial Avenue. All right, so you've got 0 cats, 1 cat, 2 cats, 3 cats, 0 dogs, all of the data there. How many of Pluvial Avenue's cats share their home with at least 1 dog? All right, so at least 1 is the key here, at least 1 dog. So the good way to do this is to figure out which rows and columns you need to include, basically. Now, 0 cats, we don't need to do any of that column, right? Because none of them, there's 0 cats there, right? There's 1 dog, 2 dogs, 3 dogs, but no cats, and we only want to know about how many cats, right? All right, with at least 1 dog, so I'll just cross that out. We don't need any of that. Now, 1 cat with 0 dogs, we don't need that. 2 cats with 0 dogs, we don't need that. 3 cats with 0 dogs, we don't need that. That means we have to count all of these ones, right? I'll just draw around it. All right, actually that's a bit messy. I'll try and keep it, yeah, all the way around there. Okay. Now here's a common error a lot of people would make in this question. They would just add it up. They would go 8, 13, 14, 22, 31, 34, 36, 40, 42. There's your answer, D42. Can you spot what the error was? Okay, how many cats? Right, so everything in this column is only 1 cat, so it stays as the number it is. But this one is 2 cats, and we're asking how many cats. So all of these numbers have to be multiplied by 2. And this one, 3 cats, they all have to be multiplied by 3. All right, so we can keep 8, 13, 1. I'll just write the numbers down so you can track it. 8, 13, 1, that's 14. 8, 17, 20, but times 2 is 40. And in the third column, 2, 6, 8, times 3, 24. Add them together, 14 and 40, 54 plus 24, 78. All right, 78 is the answer there. I'll just write that in. Yeah, that's one where you've got to pay attention to what the question is asking you. C, 78. All right, Sarah lives in a large city. All right, again, this type of vague language on the coast. Her younger cousin Marley lives in a small town with fewer than 1,000 residents. Marley has visited Sarah several times during the past 5 years. In the same period of time, Sarah has visited Marley only once. Based only on the information above, which of the following statements must be true? Right, which must be true? All right, now this question could be a little bit tricky for some students. They might get confused by the information overload. All right, because there's a lot of subjective information. All right, Marley likes Sarah better than Sarah likes Marley. Sarah thinks small towns are boring. So these are all subjective opinions. Marley wants to move to the East Coast. Yeah, we don't know about that. Right, this is the only one that could be a fact. Sarah is older than Marley. And yeah, it's given here in this word. It's her younger cousin, Marley. So Sarah lives, she has a younger cousin. So the answer is C. Sarah is older than Marley. So it's not a really hard question, but it's one you have to make sure you read carefully and you don't get distracted by the information. It's a good example of something called narrative fallacy, where you get given a whole heap of extra information that has nothing to do with what the question is asking you. All right, it is logical to conclude that it is more dangerous to ride in an automobile than to ride on a motorcycle. After all, the National Safety Council estimates that one person in 19,000 will die each year in an automobile, while only one out of every 73,000 will be killed as a motorcyclist. Which of the following studies would be most useful in assessing the validity of the argument above? All right, so straight away in this sort of data, this is a good example of using relative data versus absolute data. All right, it's like saying how many people would get killed in doing some really obscure activity that almost no one does. So it should be clear to most people, although you're not supposed to really bring outside information into this type of question. Most people would realize that many more people drive than ride a motorcycle. So these statistics are not that meaningful. Right, so you should keep that in mind while you look through, and you would already be forming an opinion of what the correct answer might be. Right, and it's actually will be D. Right, comparing death rates per 1,000 members of each group rather than comparing total number of deaths. Right, that's a common trick that's used with statistics. They might say something like, last year, 10,000 people died in car accidents and only one person died skydiving, right? So therefore skydiving is much safer. And that can be very convincing for a lot of people. But actually you might learn that, well, that was the only person that went skydiving. So 100% of skydivers died, while there might be, a billion people in driving an automobile. So the percentage of people dying in accidents is actually really, really small. And when I would teach about that to students this year, I would talk about things like COVID, because that gives a context for students to understand the way statistics can be manipulated. You'll often hear a percentage given when that sounds like it's not much, right? Like not many people died. And then you would give an absolute figure when you wanted the figure to seem large. You would say 200,000 people died or something, but without any relationship to the total population, it's impossible to make sense of either statistic, really. All right, question 12. A recent study found that those businesses which engage more with social media had more financial success than businesses which did not. The businesses which were the most engaged saw their revenue grow by 18% over the last year, while the least engaged saw losses of 8%. Since social media, that's again your sort of cue to the conclusion, since social media is the future of communication. See, and that again seems to be an assumption. This is not an assumption question, but yeah, why are they saying that? Right, it just sort of leaps there. It can be seen that businesses should interact more with social media in order to maximize their profits. Which one of the following is the best statement of the flaw? Right, so a flaw is incorrect logic. It ignores the fact that not all businesses use social media. No, not in this case. It's only comparing the ones that did and didn't. It assumes that businesses that do not use social media will collapse. No, it doesn't say they'll collapse. It just says they'll lose revenue. It assumes that participation in social media causes an increase in profits. Yeah, that'll be the correct answer, I think, all right, because this is something that's very important in arguments. It's something called correlation, not causation, right? You could be a complete coincidence those businesses that use social media. See, it could be because they're successful, right? It might be, you're a really powerful, successful company, you got lots of profit, so you can spend money on social media and your profit increases, right? The ones that didn't use social media, they might not have the money to spend on social media, so they might just go downhill as a result of their overall actions, not due solely to not using social media. So C is the answer there. All right, the next question we have here shows us an unusual dartboard is used in a playground game. All right, and we've got some numbers there. 8, 11, 18, 21, 24, 30. Put them in order. In order to win the big prize, contestants must score. All right, so must is an important word here. Exactly 50 with 3 darts, all of which must be in different sectors. Which number must, so that word appears again, must they hit with one of the 3 darts in order to score 50? All right, so what you want to do here is find the combinations that you could get to make 50. So let's have a look. We can have 8. What else can we add? 8 and 18, that'll be 26. And we can add 24, and that'll give us 50. What else can we do? All right, 11, 18, what does that add up to? 29, and we add 21, 50. All right, are there any other possibilities? So you can see there that we increased 8 to 11. What if I go to the next smallest number would be 18. I can't include that with 2 other bigger numbers. All right, so those look to be the only 2 possibilities. Now someone could think, well, the answer can be any of them, right? You must hit them, but must being the key word. So if you look at both possibilities, the only number that appears in both of them is actually 18, right? 18. So 18 is the answer, C, 18. All right, this one when I did with students, I had a little bit of trouble with it. A good one to see if you can work out some multiplications that go beyond the times tables. A stamp book contains a mixture of 27-cent second-class stamps and 32-cent first-class stamps. The total value of stamps in the book is exactly $6. How many 27-cent stamps are there in the book? All right, so the way to do this, I would just use the multiple choice answers to help you solve it. So we're doing 27. 27 times 5 equals 135. And a quick way to do that is, 27 times 10 is 270, and you halve that. All right, so 600 is what we have here. 600 being 600 cents, $6. 600 minus 135 is 465. It's not going to be divisible by 32. So the second number, the number minus the amount of 27, will have to be divisible by 32 to give us an answer. All right, let's try 8. Let's try 27 times 8. All right, a trick to finding something like this out. To times something by 8, you just double it 3 times. Right, so you go 27, 54, 108, 216. Right, that's 27 times 8, 216. What's 600 take away 216? That'll be 384. Is 384 divisible by 32? It is. Right, that'll be 12 actually, right? Because 10 times 32 will be 320. Add another 2 times 32, 64. That'll get you to 384. So it's 12. So it's 8 27-cent stamps and 12 32-cent stamps. So the answer is B, 8. So yeah, again, if you've got good number sense, good multiplication skills, that should be a pretty easy one to solve. All right, in an examination, 100 students were graded either grade A or grade B in English and mathematics. 58 were graded A in mathematics and 57 were graded A in English. 30 students were graded A in both mathematics and English. How many students were graded B in both subjects? All right, so we've got If we got 58 that were graded A in mathematics, that means we've got 28 that were A only in mathematics, A only mathematics, and 27 A only English. And that's 28 plus 27 is 55 in total. And how many do we have that had an A in both of them? 30 A both. So that 28, 27, 55 plus 30, 85. How many students were there together? 100 minus 85 equals 15. 15 who got a B in both subjects. 15B. So the answer is B. Just shade that in there. All right, next question makes use of some graphical information. So 150 people who completed a customer satisfaction questionnaire rated the overall service of Gopher Travel Agency as follows. So you've got the data there, should add up to 150. Let's just check. 75, 117, 138, 150. Phileas entered this information into his computer in order to construct a pie chart. Unfortunately, he failed to enter one of the categories, and as a result, this pie chart appeared on his screen. Which category had he not entered? So basically 4 of these numbers have been entered into this pie chart. All right, so what I would look for first is I would identify this one is equal to a quarter. All right, it's the one that is the most obvious fraction. So I would look for a value that would be a quarter of 4 total values if you were only to add 4 of them together. All right, and the number that jumps out at me here is actually 27. All right, what's 27 times 4? 108. Now I know these add up to 150 altogether. We've already been told that. If I take 150, if I take 42 from 150, I'm left with 108. So I think the one he has left out is good 42. All right, good hasn't been included. Let's check. So that one I'm saying is excellent, 27. All right, this will be the biggest one. Very good. It's worth 48. Satisfactory be worth 21, and poor would be worth 12. And bearing in mind if there's only worth 108 in total, yeah, half of it would be 54, so that 48 looks pretty accurate. All right, so I think generally you're just looking for part of the graph that will represent a pretty easy to identify fraction and go from there, right? Obviously, the fastest you are at adding numbers and seeing relationships between numbers. For example, 21 is half of 42, right? So, you would look for that relationship there. 12 is a quarter of 48. So you could extrapolate from that the correct relationships. All right, the table below records the scores of 100 games in a football league. The entries show the number of games in which the teams have scored the number of goals shown in the headings. For example, there were 10 games in which the home team scored 2 goals. So let's see, home team, 2 goals, 10 games in which the home team scored 2 goals, and the away team scored 1 goal. So there's 1, 2, they meet there. In how many games were 3 or more goals scored? All right, so again, what you would want to do here is identify which ones you need to include. So we need 3 or more goals. So 0, 0, 1, 0, 2 don't count. All right, we will need 0 and 3 because that's a total of 3. All right, when this one's 1, 1 and 0 doesn't count, 1 and 1, but we will need to include 1 and 2. All right, 2 and 0 doesn't count. All right, 2 and 1 we will need to count. So basically we need to add up all of the rest of those. All right, so let's get some totals going. So 5 plus 3, in how many games were 3 or more goals? So there's 5 plus 3, 8. Sorry, it's just very frustrating using this. We're at 8, 7, 3, 1, 11, 10, 18, 20, 4, 7, 10. It's only 10 there. And 4, 6, 8. Alright. And what does that all add up to? 8, 19, 39, 49, 57. Alright, so the answer is 57 in total. That's how many games were 3 or more goals scored. So in this sort of table, yeah, it would be a good idea to draw around, get rid of the ones you don't need to include, and then perhaps to draw a box or a shape or a perimeter around the ones you do need to include. All right, so I think that is the end of the problems that I've selected to go through for the purpose of this video. So I hope some of that will help you in the thinking skills component of the selective school test. Good luck to everyone, and yeah, please just do your best. It's going to be pretty hard, I think. Just bear in mind it's going to be hard for everyone who's doing it. All right, so if you do your best, apply some solid logic to the questions, you should do quite well.